So if you remember how to solve the square root equation, the steps are the same, so it should be pretty simple. But before we actually get to solving one, let me go cover a couple of things that are going to come up if I don't cover them ahead of time. First off, when we're solving cubic equations, or like we were doing yesterday, so for example, x cubed plus 2x minus 7. That's cubic. So I know that it looks like this. This was the coordinate grid. I could possibly potentially have one real answer and two imaginary, or I could have three real answers. When you are dealing with cubics, you will always have at least one real answer because of the way it is, because it's got one arm up and one arm down. It is definitely going to cross the x-axis somewhere. It might not cross on a nice grid line. It might be a nasty irrational number or a decimal. But you will always have at least one real answer. But you might have two imaginary answers. This one would produce two imaginaries if, for example, it went like that. That would be one real. This one over here is real because it actually crosses the x-axis. And then the other answers are floating around in never, never imaginary space. So, but you know you'll always have at least one. You still have to be able to find the imaginary answers regardless. Okay, so that's where the quadratic formula or synthetic division, factoring, all that stuff comes into play is to find your two imaginaries. Okay, now I know that there's going to be three answers because of this. Because it's cubed to the third degree, and that tells me by the fundamental theorem of algebra that I'm going to have three answers. Now, we're about to solve cube root equations. So now I'm going to solve something that looks like this. They do not produce three answers because this is not a polynomial function. So the fundamental theorem of algebra doesn't apply. Because if I were to write that with an exponent, it would be to the 1/3 power. And there's no way to get 1/3 of an answer. So in this case, when we're doing cube roots, they may have one answer, they may have two answers, they may have three answers, but you're not guaranteed to always have three, like you are with cubics, because the fundamental theorem of algebra doesn't apply to this. So, but solving them is easy. If you think back to when we solved, this principle is true for this too, when we solved quadratics like that, they have two answers. When you solve square root problems, sometimes they might have two, but sometimes they only have one, because radicals of any kind are not polynomial functions, and the fundamental theorem of algebra doesn't apply. So you can't tell how many answers you're going to have just when you start the problem. Okay, so with that said, let's look at the page that says solving cube root equations. The idea behind solving a cube root equation is to clear the cube root by raising each side of the equation to the 3rd power. So now these are the steps that I'm talking about that are just like the steps we used for radicals, regular square roots. Number 1, isolate the cube root if you can. Now today, on this particular exercise, all of them we will be able to isolate. But if you think back to when we did square roots, every now and then you can't. If you had a square root on both sides, there's no way to isolate them because you move them all this side, then you move one back, and you can't ever get them by themselves. But if you can isolate it, it'll make it easier. Then the second step is to cube both sides of the equation. That will be to get rid of the radical. And then third, you'll just solve for x. All right, so if we're looking at A, I want to first isolate the radical. So I'm going to take this minus x and move it over, or add x, whichever way you want to look at it. So now I have the cube root of x equals x. So now your radical is isolated, because it's all over there on one side by itself. So the next step says cube both sides. Cubing the left just cancels the radical. So now I have x equals x cubed. Now, if I'm going to solve this, just like when we solve square root problems, or any other problem for that matter, if you have an x and an x squared in the same problem, you need to move everything to one side and factor. Same thing's true if you have an x cubed and an x in the same problem. I'm going to move everything over so that I can factor this.
The radical is the whole entire thing.
The radical was just this side.
So you got rid of that 3 also?
Yes, yes, I'm glad you asked that.
Um,
It's like connected. The little 3 is like in there and it's connected to it, so yeah. So now I have this, 0 equals x cubed minus x. Now, I'm going to factor out an x, because they have a GCF of x. Alright, so I have x and in parentheses x squared minus 1. Now you've factored it. Once you have factored something, you can set each of the factors equal to 0. So there's my first factor. So x equals 1, x equals 0. And then x squared minus 1 equals 0. You can either factor that as a difference of 2 squares, or you can move the 1 over and take the square root. Doesn't matter, you'll get the same answer either way. I'll just move the 1 over. So I have x squared equals 1. Take the square root, and you get x equals both positive and negative 1. So this particular one has 3 answers. I have the answer x equals 0, and then I have x equals positive and negative 1. Are we okay so far? Pretty easy? So if you had recognized right here that this was a difference of 2 perfect squares, and you'd have factored it further into x minus 1, x plus 1, you still would have gotten x equals 1 and x equals negative 1. So, 2 ways to get the same thing. Alright, B. We're going to, following step by step, the first step up here says, isolate the cube root if you can. My cube root is already isolated, because all those numbers are underneath it. So there's nothing I can do about any of that, it's all grouped together. So I'm going to move on to the second step, which says cube both sides. Cubing a cube root cancels the radical. So on the left, you're left with x squared plus 2x plus 8 equals 8. Plus 2 to the third power is 8. Now the next step says solve for x. Well, just like a minute ago, I now have an x squared and an x in the same problem. I need to factor. Since I need to factor, I need to set it equal to 0. So I'm going to subtract 8 from both sides.
Could you just do the quadratic formula also?
You could, but quadratic formula, you do have to set it equal to 0 also. So, yeah, but yes, absolutely. Looks like it has a GCF of x. If I factor out an x from x squared, I'm left with x. Factor out an x from 2x, and you're left with 2. And now I have 2 factors. Once you get to something in factored form, you can set each factor to equal to 0. So I have x equals 0 and x plus 2 equals 0. Subtract 2 from both sides. So x equals negative 2. So this one has 2 answers. So far so good? Okay, so you try C.
When it says to check your answers, it just means check graphically.
Oh, no, it means just plug them back in. I don't know if you remember, but with square roots, you can get, with radical square root equations, you can get extraneous roots. So you always have to plug them back in and check them. And you should plug these back in and check them too, but they don't generate extraneous roots. And I'll explain why in a second. first step is to isolate the cube root. It's already isolated. So I get to move on to step 2, which says to cube both sides. Cubing the left cancels the radical, and I get x minus 4x equals 0. I kind of wonder if this is a typo, but either way. X minus 4x is negative 3x. Divide both sides by negative 3, and x equals 0. This one only has one answer. That one's really, really easy. Okay, so let's look at D. Now, step number 1, isolate the cube root. Looking at D, doesn't even look like I have a cube root, but you do. Remember, it was a while back, but we did the exercise with the balloons, that we popped the balloons. When you have what's called a rational exponent, or some people will call them fractional exponents, that is a radical. It's just another way to write a radical. So, I'll rewrite it as a radical, and I'm going to do this problem both ways. Because there's a reason why we use fractional exponents. They're easier. But, if you're used to radicals, you might want to see it both ways. So I'm going to write it both ways, and I really don't care which way you do it. Just get right into it. So I'm going to leave it like it is, right here. And then over here I'll rewrite it as a radical. Remember, the bottom number goes in the crack, so that's where it's a cube root. The top number goes outside the parentheses. So these two equations are identical. So it doesn't really matter which way you choose to do it. Now, I'm going to solve it the radical way first, because that's what we're doing right now. So I'm going to solve it that way first, and then I hope that you'll see the other way's actually easier. But let's solve it this way first. Isolate the cube root. That 3 is in front. I can get rid of it by dividing by 3. So now I have the cube root of x plus 1 squared equals 4. Alright, now the next step says to cube both sides. So I'm going to cube this and cube this. Cubing the left just cancels the radical and leaves me x plus 1 in parentheses squared equals 64. Everybody okay? Now, in order to keep solving this and get x by itself, I have to get rid of those parentheses. The parentheses are there because it's squared, so you have to take the square root now. That gives me x plus 1 equals, now don't forget, when you take a square root, there is both a positive and negative answer. So plus and minus 8. So now I'm going to subtract 1, which means I'll have x equals 7 and x equals negative 9. Alright, so that's solving it the radical way. Using radicals, not radicals, and that's crazy, but let's solve it the other way. Principle's the same. You're going to isolate what would be the radical, so divide by 3. And I get x plus 1 to the 2/3 power equals 4. And right here's where it's easier. Because over here, this took me 2 steps. I can do it in 1 if I use my fractional exponent. If you remember that worksheet we did with the balloons, I can get rid of a fractional exponent by multiplying it by its reciprocal, or raising it to its reciprocal power. So that gives me x plus 1, and I can plug that in, actually that gets rid of my parentheses. I can plug 4 to the 3/2 power in my calculator, and it gives me 8. But you have to remember it's both positive and negative 8, because it's a square root, or it has a 2 on bottom. The reason you have to remember that is your calculator, anytime you take a square root, what kind of answer does it give you? It just gives you the positive answer, right? That's called the primary root. It's the one we use the most, so that's why they call it that. Or the principal root. It never gives you the negative answer, but it does exist. So you have to remember that it's there. You have to do that same thing for raising something to the 3/2 power. And then I subtract 1 from both sides, and I still get x equals 7 and x equals -9. So it doesn't matter which way you want to do it. The square root way, if you're more comfortable with it, the radical way, if you're more comfortable with that, then do it that way. I just think raising things to the reciprocal power is faster. So whichever way doesn't matter.
Can you rewrite the cube
Yes,
root into the,
it'd be the 1/3 power. If there's no other exponent on anything, you just write it to the 1/3 power. Okay, real quick because it kind of came up just kind of a second ago. However, when you take a square root, there are 2 answers always. But when you take a cube root, there's not. There's only 1. Let me show you why. Because if I'm taking, let's do 64 because it's a perfect square and a perfect cube. So if I take the square root of 64, we just said it's both positive and -8. Why? Why is it both?
Because negative times negative equals positive.
Right, so -8 times -8 still equals 64. But if I do this and take the square root of 64, the cube root of 64, it's just 8. Why is it not, sorry, it's not 8 at all, it's 4. Why is it not -4 though?
Negative 4 times -4 times -4 equals -64.
Very good. It's because you're using 3 of them. So if I wrote down -4 times -4 times -4, those 2 would make positive 16 times a -4 would be -64.
Which is imaginary.
So it only works when you, this, if it's odd, it doesn't matter what odd number it is. Cube roots, 5th roots, 7th roots, they all only have 1 answer. If the number in the crack is even, it'll have both the positive and negative answer. For the same reason that this does, okay? So that's just something you kind of have to remember. Since your calculator only gives principal roots anyway, it's only going to give you the positive root. But that also means you can plug negative cube root of 64 in your calculator and it'll do it. Because you can take a cube root of a negative number. They don't create imaginaries. Only even roots create imaginaries. So. Okay, so E, I'm going to do this one both ways. We can do it just like it's written, or we can write it as a fractional exponent like this one was. So I'm going to rewrite it as a fractional exponent. So this would be x plus 1. Remember, the bottom goes in the crack. So this is going to be 5/3. Plus 1 equals 97. Or, I'm going to leave it like it is. Alright, so let's solve it the radical way first. You need to isolate the radical. So this time I have 2 things I need to do before the radical is isolated. So first I'll subtract 1. Radical isolated. So now I need this next step says cube both sides. This is going to be a huge number, by the way. x by itself, and it's got that 1 trapped with it inside the parentheses because of the 5th power. So I'm going to take the 5th root. And if I take the 5th root of the left side, I gotta take the 5th root of the right. Now, if you have forgotten, in your calculator you can take a 5th root. You have to put the root in first. So I hit 5 first, then hit math, and it's the 5th one down, the one that has an X. And that'll put it in the crack like it's supposed to go. So that's a 5th root of 32,768.
Could you also take the reciprocal?
Yes, and that would be easier. Alright, so when I do this, I get x plus 1 equals 8. It's a 5th root, so there's only one answer. Because it's an odd root, so there's only one. So subtract 1 and you get 7. Alright, so now I'm going to do it the rational exponent way. Subtract 1. Divide by 3. And then right here, I can raise this to the reciprocal power. So I'm going to raise it to the 3/5. And when you do, that cancels the exponents on the left, and it gives you 8 when you plug that in your calculator. And when you plug it in, you just have to plug it in just like that. So 32 raised to, you can use the fraction part if you want to, or you can write it as a division problem, it doesn't matter. Was it 5/3 previous? And then subtract it. And that's it. So it doesn't matter which way you do it, and I don't really care. It doesn't matter. I will say this though, you do, okay, is everybody signed up for the SAT? You need to. If you haven't, you need to. The SAT, June 4th, is June 4th, that very first one, honestly, now a couple of you sophomores will be way better. I would still take it. I would still take it in June. Then you'll have a score and it'll be great, but you'll be better off because you'll have pre-cal 2, and there is some pre-cal stuff on the SAT. But most of what's on it is algebra 2. Rational exponents are on there. Now, they just changed it, and I have not yet seen any released questions from the new SAT, so I don't know if rational exponents are still part of it, but they used to be. Instead of radicals, they write them all as fractional exponents. So you need to know them. Now, as far as how you calculate them, if you want to rewrite them as radicals and do them that way, then that's fine, as long as you know what they are.
Are you allowed to use a calculator in your SAT?
Yes. Yeah. But just so you know, because of that, it is created to use a calculator. However, and I have the information about the new one, I just need to read a little bit more. Every question on it, you are able to answer without a calculator. So if, for whatever reason, some people don't like to use them, and if for whatever reason yours stopped working or whatever, then every question is possible to answer without a calculator. But they're definitely, you're allowed to use them, so they definitely hear things kind of that way. Okay, so I have a worksheet to do. Super easy. It starts with number 7 because problems 1 through 6 were all graphing, and I didn't want to graph them, so I figured y'all probably didn't want to graph them either. So they were just transformations of cubics. So cubics transform just like all other. We've done how many different functions, and they all transform basically the same way. So here, I can't count.
Are you gonna run this Saturday?
I won't be here. I'm gonna be out of town. I know. I'm really kind of bummed because I wanted to.
Is this one number 7?
Yeah, because I didn't want y'all to have to do the graphing.